Hello, Matt here from chemistrystudent.com. In this video, we're going to look at hydrogen bonding. We're going to talk about what hydrogen bonding actually is, how hydrogen bonds form, and why substances that exhibit hydrogen bonding have higher melting and boiling points than we would otherwise expect. Before we talk in detail about hydrogen bonding, there are a few essential ideas you need to be comfortable with. Covalent bonds are atomic bonds that form when two atoms share a pair of electrons. An atomic orbital from each atom overlaps and creates a new area of electron density between the two atoms. The positively charged nucleus of each atom is attracted to the shared electron density, and this pulls the nuclei closer together, creating a covalent bond. Inside a single bond, there is one pair of electrons. Molecules are groups of atoms covalently bonded together in units that make up molecular substances. Intermolecular forces are forces of attraction that arise between molecules within a molecular substance. It is intermolecular forces that get broken or overcome when a molecular substance melts or boils. The stronger the intermolecular forces holding its molecules together, the higher a substance's melting and boiling point. Electronegativity is the ability or tendency of an atom to attract a pair of electrons towards itself in a covalent bond. Atoms of elements with a higher electronegativity than the atom they are covalently bonded to can pull the electron pair slightly towards themselves. This gives the atom a partial negative charge and the other atom in the bond a partial positive charge. The bond has a dipole moment and is described as being polar, as it has a positive end and a negative end. The size of the polarity in partial charges is based on the difference in electronegativity between the two bonded atoms. The larger the difference in electronegativity values, the more polar the bond. Electronegativity increases for elements as you go across a period in the periodic table and decreases as you go down a group. Recap done? Let's go. Hydrogen bonds are intermolecular forces that can arise between molecules that contain an OH, NH or FH covalent bond. Oxygen, nitrogen and fluorine are the most electronegative elements. They are found in the upper right corner of the periodic table. Remember, electronegativity increases across a period and increases up a group. When either of these three elements covalently bonds to hydrogen, a highly polar bond is formed. Hydrogen has a low electronegativity, and the oxygen, nitrogen or fluorine atom easily pulls the electrons in the covalent bonds towards itself, ending up with a large partial negative charge. This leaves the hydrogen with a partial positive charge. The interesting thing with hydrogen in this situation, though, is that it was only really made up of one proton and one electron before it formed the covalent bond. Meaning that if the electrons in the covalent bond are pulled away from the atom, a single proton starts to become exposed. This highly polar bond and exposed proton enables attraction between the same types of bonds on neighbouring molecules. The partial negative oxygen, nitrogen or fluorine bonded to hydrogen in one molecule will be attracted to the partially positive hydrogen atom from the same type of bond in another molecule. This is really just an example of a permanent dipole-dipole intermolecular force. These have been covered in a separate video, check the links in the description below. The thing is though, the oxygen, nitrogen or fluorine will have a lone pair of electrons as well as the partial negative charge already mentioned. If positioned correctly, a lone pair of electrons on either of those atoms will be attracted to the exposed proton from the hydrogen atom from a neighbouring molecule. The force of attraction is considerably stronger than for a normal permanent dipole-dipole interaction between polar covalent bonds, and is called a hydrogen bond. They are the strongest type of intermolecular force. Only molecules containing OH, NH and FH bonds can form these type of intermolecular forces due to the very high electronegativities of oxygen, nitrogen and fluorine, and the low electronegativity of hydrogen. The relative strength of hydrogen bonds compared to permanent dipole-dipole forces can easily be seen if we look at the melting and boiling points of substances that can form them. Water, H2O, has a melting point of 0 degrees Celsius. Hydrogen sulfide, H2S, has a melting point of minus 85.5 degrees Celsius. Sulfur is only one period below oxygen, and the shape and structure of the two molecules are very similar. The huge relative difference in melting points is down to the ability of water to form hydrogen bonds. Hydrogen sulfide molecules are unable to. As the hydrogen bonds are stronger than standard dipole-dipole forces in the hydrogen sulfide, more energy is needed to overcome them to melt or boil the substance, giving water a higher melting and boiling point. The same trend is seen with ammonia, NH3, compared to phosphine, pH3. Ammonia has a melting point of minus 77.7 degrees Celsius and phosphine minus 132.2 degrees Celsius. The strongest type of intermolecular force between molecules in ammonia is hydrogen bonding, whereas the strongest type of intermolecular force between molecules in phosphine is permanent dipole-dipole interactions and forces. Hydrogen fluoride, HF, has a boiling point of 19.5 degrees Celsius, and hydrogen chloride, HCl, has a boiling point of minus 85.1 degrees Celsius. Again, HF molecules can form hydrogen bonds between themselves. HCl molecules can only form permanent dipole-dipole interactions. Hydrogen bonds are strong then, although they are still much weaker than atomic bonding, covalent, ionic, and metallic. So, to summarize, hydrogen bonds are intermolecular forces that can arise between molecules that contain an OH, NH, or FH covalent bond. OH, NH, and FH bonds are highly polar due to oxygen, nitrogen, and fluorine being the most electronegative elements and hydrogen having a low electronegativity. Electrons in these covalent bonds are pulled towards the oxygen, nitrogen, or fluorine, making them partially negatively charged with a high electron density around them. The hydrogen doesn't have any other electrons around its atom, and this means when the bonding electrons are pulled away from it, essentially a proton, with a positive charge, is left exposed. There is a strong attraction between the oxygen, nitrogen, and fluorine with a lone pair of electrons and the exposed proton from another OH, NH, or FH bond. This attraction is called a hydrogen bond. Hydrogen bonds are the strongest type of intermolecular force and explain why molecules with OH, NH, and FH bonds have higher melting and boiling points than similar sized molecules that don't have those bonds. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.